Section 1.5, Postulates and Theorems Relating Points, Lines, and Planes. This particular section has several different postulates in there that we're going to go over in this video. But the theorems we're going to use in class because theorems can be proved, and we're going to talk about that in class tomorrow. First postulates have to do with lines. Notice that if there is no name given for the postulate, like ruler postulate or protractor postulate, that means you have to write out the entire postulate. You can paraphrase, but only if you say exactly what needs to be there. So the first postulate is a line contains at least 2 points. If you're given a line, you can identify 2 points on that line. We're going to call them A and B because every line contains at least 2 points. The second postulate also deals with lines. If I have 2 points, there's exactly one line that connects those 2 points. Through any 3 points, there is at least one plane. So I have those 3 points. You can see that they're collinear. If you think about an open book, you have several planes there that those 3 points and the line that contains them will all be on that plane. For instance, if you look at the cover, the bottom cover, call that plane P. Line A, B, C is on that plane. It's also on plane R. It's also on plane T. So there's at least one plane that will contain those 3 points. But if I have non-collinear points, there is one and only one plane that will contain all 3 of those points. The next postulate also is talking about planes, and if there are 2 points that are lying on a plane, lying in a plane, are contained by the plane, then the line that contains those 2 points is also in the plane. The next postulate, if 2 planes intersect, then their intersection is a line. The points that are in common are all the points that are shown that go from endpoint A to endpoint B. Now, what's shown is a segment, but you know that if you extend it in both directions, that is actually a line. The last postulate we're going to talk about is the space postulate. Space contains at least 4 non-coplanar points. You'll notice that points A, B, and C are the front of that box. Point D is an opposite corner. There is no plane that contains all 4 of those points, so they're non-coplanar. That represents space. That's what gives us our 3rd dimension. This last postulate is something that we've been using in class. However, we've not identified the real reason why we were allowed to do the things that we've been doing. This concept doesn't show up until Chapter 2, but I would like to give it to you now. This is called the linear pair postulate. The linear pair postulate says if the exterior sides of 2 adjacent angles form a straight line, then the sum of the angles is 180 degrees. We know that a straight line is 180 degrees. And we know that angles 1 and 2 are adjacent angles. And the outsides, their exterior sides, are a straight line. Therefore, the sum of the measures is 180 degrees. Complete your note sheet and be ready to talk about the postulates tomorrow.